Good morning, students. On continuation of AC motors, in this session we are going to learn new techniques how to change the speed of given 3-phase induction motor, whether it may be. Here we are going to concentrate in slip ring induction motor. As we have discussed previously, stator side, how the induction motor speed can be varied by changing the frequency, number of poles, voltage. And coming to the towards the rotor side, where rotor winding is wound, these terminals taken out through 3 slip rings. From 3 slip rings, it is connected to the rotor rheostat. From that rotor rheostat, we can add some extra resistance into the rotor circuit, or we can inject some rotor frequency equivalent to the rotor frequency voltage from the rotor circuit from externally, and we control these motors by using the cascading method also. These 3 small topics we are going to cover in this session. As we know that the induction motors are constant motors, it runs on rugged, its construction is rugged and cheap and best. Speed control is taken some complication as comparing to our DC shunt motor, where in DC shunt motor we have seen in second year level we can control the speed by using the field control method or armature control method by changing just inserting some resistance in series to the circuit. But in this case it is not possible to insert the extra resistance in the circuit. So we can insert, but what will happen comparing to the DC motors? Here the losses are very high. It leads to low efficiency of induction motor. Hence our forefathers found some techniques to control the speed of induction motors from stator side and rotor side. In stator side, how the speed is controlled by changing the number of poles, by changing the input voltage, by changing the frequency, that means V by F ratio, by maintaining the constant. How the speed changes, we have seen with help of the graphs also, torque slip graph. In this session, we are going to interesting topic, that is how the speed of slip ring induction motor can be changed with the help of adding some resistance in the rotor circuit or by injecting the external voltage into the rotor circuit. Let us see. On completion of this period, you would be able to know the speed control of induction motor by injecting voltage in rotor circuit method, speed control of induction motor by changing the rotor resistance, and speed control of induction motor by cascading method by connecting the 2 motors set to the 2 motors side by side, common rotor shaft. So do you know on which factors the speed of induction motor depends? So what is the speed? So NS synchronous speed or speed of the motor is directly proportional to the 120 F by P, where F is the supply frequency, P is the number of poles. The supply frequency is given by the DISCOM people, we cannot change. Indian frequency is 50 Hz, that may be plus or minus 5% tolerance. Above this one we cannot change, whereas the speed can be changed with the number of poles. At the time of the manufactured itself, the winding is wound for a fixed number of poles. So there is not possible to change the poles intermittently. So frequency and number of poles cannot changed at middle. That purpose, so we require the variable frequency is required and a variable pole methods is required. The separate special winding is provided in the stator circuit. How the speed is changed we have seen in previous classes. Okay, so this is the one formula, and another formula already we know that n is equal, rotor speed is equal 1 minus s into ns. That means the slip also plays a vital role to change the speed of the machine. If speed increases, then automatically rotor speed decreases. Okay, what is the slip? Slip is the ns minus n by ns. Okay, so here the rotor speed can be changed with help of these factors. What is the formula for speed of induction motor? We have seen just now. What happens if the voltage is injected into the rotor circuit? So what is the meaning? Here you can see that means this is a stator and here is a rotor. If rotor taken out, so we are going to see this with the rotor, and rotor has the rotor winding and it has the shaft. There is a slip rings, 3 slip rings is provided in slip ring induction motor. It is connected star and taken out through the brushes to the outside. At the time of the manufacture itself, the winding has some resistance, small resistance, and by adding some extra resistance from outside, so this is a capital R. So small r plus capital R leads to rotor winding resistance increases. It can helps to produce a T starting torque produced. So torque is directly proportional to the S into E square into R2 by Z square. Okay, so here so T starting directly proportional to the resistance. Initially we are going to increase the resistance, the starting torque increases. That is the beauty of the slip ring induction motor. So this is the one provision. So not only to increase the starting torque, we can also change the speed in this case. That is what happens if the voltage injected into the, so instead of this resistance, if you are adding some external source, you add some resistance in the rotor circuit. So already this induced EMF due to the rotating magnetic field is called ER, rotor EMF, and from external source we are going to inject the voltage, suppose ER dash. If this induced voltage ER, injected voltage ER dash, or both are in phase, then the resistance value decreases. If resistance value decreases, slip value increases and rotor speed changes. If this induced voltage is opposite to the already existing voltage, then resistance value changes, then correspondingly speed also changes. This is a concept. Okay, let us see in details. What happens if the slip decreases? Slip decreases, speed will increases, because slip and speed always inversely proportional. What happens if the rotor circuit resistance is changed? The slip will changes, correspondingly speed changes, and correspondingly the starting torque also changes. Speed of the induction motor is given by, so well known formula, n is equal to rotor speed is equal to synchronous speed into 1 minus slip times. When synchronous speed ns is equal to 120 f by p and slip is equal to, already we know that slip is equal to rotor copper loss Pc by rotor input P2. Hence, so you know that Here one good equation, dear students. What is that one? So here we know that rotor copper loss, okay, rotor copper loss is equal to rotor input into slip times. Here what is happen? Rotor input is constant. Now the rotor copper losses is equal 3 into I square 2 into R2 is directly proportional slip. Here what is happen? The R resistance and slip are the directly proportional related to this one. If you are adding some resistance in the rotor circuit, the slip will change. Okay, so that is the concept of this lesson. Hence, from the above expression, it can be concluded that the speed of the motor can be changed either by changing its synchronous speed or by changing its slip. What is the slip? Slip is equal to ns minus nr by ns, that is the actual synchronous speed minus actual rotor speed. The speed of induction motor by injecting the voltage in rotor circuit from external source. The speed of induction motor can be controlled by injecting a voltage of slip frequency into the rotor circuit. Dear students, what happened? Here initially what will happen? At motor is under standstill condition, n is equal 0 at standstill condition initially. Whenever the 3-phase supply is given, then it produces a rotating magnetic field in the air gap and sweeps the rotor conductors. It produces the rotor EMF is equal E2. At that condition, n is equal 0 and slip is equal to 1. Then what is the formula? That is here rotor induced EMF ER is equal to S into E2. So S is equal initially 1, whereas the rotor induced EMF is equal to standstill voltage. At that time, the frequency of rotor induced EMF Fr is equal to S into F. So F is a supply frequency, that is 50 Hz. Then S is equal to 1. So rotor frequency also 50 Hz. Okay. Initially voltage is equal to E2 and Fr is equal to F50 Hz. Once the rotor starts to rotate in the same direction of rotating magnetic field, it try to catch the RMF, then rotor will rotate in the speed. Once the rotor picks up the speed, the slip value changes. The slip value decreases. If slip value decreases, instead of 1, it maybe goes to the 0.4 or 0.2 like that. Then what is happened? The rotor induced EMF also affected and the frequency also affected. Okay. So that is the meaning of this one, slip frequency into the rotor circuit. The slip also the value changed. The slip was from the 1 to it reduced to this fraction of 1. If the injected voltage in phase with the rotor induced EMF in equivalent to decreasing the rotor resistance, that means what are the rotor resistance ER in phase with the external resistance, that is equal to the rotor induced from, for example, take the dash, the external source. If this voltage and this voltages are in phase, so this direction is this phase and this direction in phase, then automatically difference, due to this difference, that resistance, rotor resistance R2 value decreases. Okay, resistance value decreases. Hence the slip decreases, or decreases, slip also decreases. If slip decreases, n increases, speed will increase. Okay. So, such a way that we are going to control the speed. Okay. So, dear students, if injected voltage into the rotor circuit is in phase with the already induced voltage in the rotor circuit in phase, then rotor resistance value decreases, then slip also decreases, speed will increase. So, by changing the phase angle, whether it is in phase or out of phase, we are going to control the speed of induction motor. If injected voltage is in phase, opposition to the rotor induced EMF is equivalent to the increasing the rotor resistance. If rotor resistance increases, slip percentage also increases. If slip percentage increases, means the rotor speed will decrease. Hence, slip increases and speed will decrease. A large and smooth variation of speed is possible by this method here. So, simple by injecting the voltage. So, magnitude and phase angle with the existing rotor voltage, we are going to change a large variation of the speed with a smooth operation is possible. Okay. However, so it requires an auxiliary mission, just a scarge motor or a brush shifting motor. It's a large motor, a complicated motor, a costly motor is required. It is capable of injecting the correct slip frequency voltage, that voltage within phase with or out of phase of the rotor. So, into the rotor circuit. That means, so we require the large costly of the equipment is required, and the operator also skilled person is required to close that switch. Therefore, it is a costlier and used with motors of a very large rating. Nowadays, these motors are rarely used because of the bulky construction and prohibitive cost, higher cost. But in this method, any speed within the working range can be obtained smoothly. Now, so second case, what you have seen first case, by whatever the rotor winding induced voltage ER. So, this voltage extra voltage ER from external voltage and this voltage. So, both voltages, by changing its phase angle, we are going to change the slip, correspondingly change the speed. That is the first case. Okay, simple dear students. Now coming to the second topic, that is what is the topic? By changing the resistance. Now what is happened here? Okay, here what is happened? This is the slip ring, this is a winding, and this is connected to the shaft. It is the slip rings. Okay. Now what is happened? So we are connected this one and we taken outside. Now here we have some resistances connected here. So this is connected here, this is connected here, and this connected here. So previous case, instead of this one, we connected some extra source by injecting that voltage into the rotor circuit. In this case, instead of injecting the external source, so we connected to some resistance in series with the rotor winding. Then how we are going to change its speed, and how we are going to change this? Let us see. Okay. So this is a concept here. The method is applicable only to slip ring induction motor, where it is possible to insert the resistance in series with the winding. In squirrel cage motors, rotor circuit resistance cannot be varied. That is, the bars are inserted and soldered at the both ends. By injecting the rotor resistance, by increasing the rotor resistance, so resistance in the rotor circuit can be varied. The slip increases and the speed decreases. So in previous case, what we have seen, by injecting the external voltage, that is equal to ER dash in phase with the E2 voltage in the rotor circuit. So, both are in phases, the total resistance value decreases and slip also decreases and speed increased. That means the resistance plays a vital role change the slip. If slip changes, automatically speed will change. Here, by injecting the voltage externally, we are changing the resistance. So, instead of the large size of the Cascading motor, so I can use directly by adding the some external resistance in this circuit. Okay. So, same case we are taken place by increasing the rotor resistance. Already rotor winding has the some resistance. By adding the some external resistance from the outside, rotor resistance value increases. If rotor resistance value increases, the slip value also increases, then speed will decrease. Speed will decrease. That is the concept here. Okay. The slip increases and the speed decreases. Since we know the relations, what is the relation? So, here S slip is equal to rotor copper losses by rotor input, that is the P2. Okay. Then what S is directly proportional to rotor copper. What is the rotor copper losses? So, for 3 phase 3 I square R2. Here, so we take the constant, then R2. So, resistance depend upon the slip. If resistance added externally, resistance value increases, then slip value increases, then corresponding speed will decrease. Okay. So, this is the relation between these things. Okay. So, same thing we have seen by using the injecting voltage. Okay. However, the addition of resistance in the rotor circuit increases the rotor copper losses. Yes, with it reduces the efficiency. If resistance added in changing the speed, there are some extra resistance in the rotor circuit, then losses will increases, copper losses increases. That also leads to the motor efficiency decreases. Therefore, this method should be used only when the speed control is required for a small amount of the duration, short period we can adapt to sacrifice some losses. Okay. When external resistance is put in series with each phase of rotor circuit, the rotor copper losses increases because 3 I square R losses. Slip is equal rotor copper loss, already we know that. If the rotor input remains constant, P2 is the constant, the increase in rotor resistance will increase in the slip. So, thus the motor speed NR is equal 1 minus S into NS will decrease, speed will decreases. The speed below normal only can be had in this case. The main disadvantage of this method is that with increase in rotor resistance, rotor copper loss also increases, which proportional to the reduction in speed as well as the efficiency. Hence, this method is used where speed changes are needed for short period only. Okay. Also, this method gives a poor speed regulation. What is the regulation? The variation of the speed with the load becomes higher in the figure. You can see this diagram. Dear students, let us see from the load on the motor is off load. If load is increased to the full load, then how this corresponding changes takes place. Let us see, this is R1 where having the resistance initially in the rotor circuit. At that condition, from full load to, this is the off load to full load, then the speed is off load, this is a full load here, the speed changed, you can see it. At off load, the speed is more, when load added full, then speed decreases to this much, the difference this here. Okay, this is a R1. If some extra resistance added into the rotor circuit, then characteristics change to this direction. At that condition, if the load, if increase this one, this is the speed at off load, if at that condition load added, then automatically speed decreases furthermore. That means from here off load to full load, the speed changed, the speed decreased a higher value here. Okay. So, this is the resistance without adding in the rotor resistance. If resistance added in the rotor circuit, then its characteristics, maximum slip, maximum torque is produced also changes at a different speed. Okay. So, these characteristics are similar to the previous case. Okay. So, these are the torque slip characteristics. So, from the figure, change of the load from off load to full load, the variation of the speed is from the N1 to N2, speed decreases with R2 as a rotor resistance. Variation of the speed is from the N3 to N4 with the resistance added in the rotor circuit with help of the external rheostat. The speed is decreased, which is much higher as compared to the R2, the rotor circuit. Okay. So, these are the some relations, dear students. Okay. Now, topic, that is some speed control of induction motor by cascading method. So, what we have seen, so speed can be controlled by injecting some voltage externally into the rotor circuit. Second one, by adding some resistance in the rotor circuit, and third one, so we are going to see is a very interesting, that is the cascading method, speed control of induction motor by cascading method. That means two vehicles or the two speed changes, two vehicles, I can use this thing. Okay. So, here what is the basic concept, dear students? Suppose I have the one vehicle, it can be goes a speed of 80 kilometers per hour, and another vehicle having the speed, it may 40 kilometers per hour. So, here, so how we are going to use this is a one vehicle, this is a, for example, this is a my Pulsar, this is my Splendor. Now, what is happened? So, here I can attach it to this one, I can start this motor only, I can stop the ignition here. So, I couple to this one and I will start it, I will go at a speed of 80 kilometers. So, at that condition, what is the speed of this one? It is as 80 kilometers. I can get the one speed. Next time, I will start this machine, I will stop it, I attach it to this one. I can go at the speed of 40 kilometers per hour. Then what is the speed? Both motors speed is the 40 kilometers per hour. Then I can get the second speed. And third speed, I am going to get it. So, this speed and this speed I can coupled, I am going to get it, the 80 kilometers plus 40 kilometers. So, I am going to this speed and 80 kilometers and 40 kilometers I am going to, that means combination of this and combination of this I can get it. So, this is the third case, this is the fourth case. So, I can get the speed with the help of my two vehicles, two wheelers. Okay. So, similar to here also, for you take the two wheelers or you can take the two lorries, you can say, or two vans, goods vans. Okay. Now, let us see. So, here this is also called the cascading method or concatenation or tandem operation of induction motors. Okay. Three methods we can as the concatenation method or tandem method, we can see here. In this method, two motors required, at least one of which must have a slip ring type called the main motor. Slip ring induction motor is required, one is the required slip. And while the second motor is called the auxiliary motor, it may be squirrel cage motor or slip ring induction motors. Okay. So, what are the students? These are the two motors is connected, rotors are coupled. Okay. Then at the time one of this 1 meter and second motor, so one should be the compulsory slip ring induction motor, other may be slip ring induction motor or squirrel cage motor. Okay. So, the two motors are mechanically coupled as shown in the figure, you can see. So, both run at same speed. The stator of main motor, motor 1 is connected to the 3-phase supply, while the auxiliary motor, motor 2 is fed from the rotor circuit of the main motors. You can see the figure. This is called the cascading of the motors. You can see this is the one figure. Here what the motor, so this is a main motor, dear students, this is a auxiliary motor. Main motor as the slip ring induction motor. So slip ring induction motor stator is connected to the supply and it produces whatever the rotor induced EMF is connected to the slip rings. This induced EMF as an input to the second motor. Okay, it will take the supply from this supply and it induces in rotor circuit, that is a secondary, that act as a primary to the another motor. Okay, so here so this is known as the cascading connections. If the torques produced by the both act in the same direction, the cascading is called the cumulative cascading. So what that means? The whatever the torque produced by this induction motor and this torque produced by this motor, if torque produces this direction, this torque produces also this direction, then we can say that that is known as the cumulative cascading mechanism. If opposite, then what is that? That is a differential. We can say if the torques produced are in opposite direction, cascading is called the differential cascading method. Just like dear students, so differentially compound motor and cumulative compound motor in DC motors. Similarly here also, if the both torques are the main motor torque and auxiliary torque, both torques are same direction, we can say the cumulative cascading mechanism. If opposite, then we can use the differential cascading mechanism. Let us assume some simple analysis. Let us P1 is the number of poles of the main motor and P2 is the number of poles of auxiliary motor, second motor, where F is the supply frequency. Due to the cascading, 4 different synchronous speeds are possible. 1. The main motor is connected to the supply independently. So, we are going to the synchronous speed is the 120 F by P. And second, the auxiliary motor is connected to the supply independently with the main motor disconnected from the supply, then we are going to get the second speed. NS is equal to 120 by P2. So, P1 is the main motors, P2 is the auxiliary motor poles. In case, in cascading combinations, the cumulative produces the effective number of poles, that is equal P is equal P1 plus P2. So, substitute the synchronous speed NS is equal 120 by P. Here P is equal P1 plus P2. That is the another speed. In differential cascading, the effective number of poles is equal P1 minus P2. Then we are going to get the same equation. So, another speed NS is equal 120 by P1 minus P2. Such a way that, so we are going to get it. So, that is equal to 120 F by P1, that is a one speed, this is the second speed, this is the third speed, this is the fourth speed. We are going to get the 4 variation of speeds. Okay. So, this is a one example of cascading method. This is the idea, dear students. Okay. Let us summarize what we have seen in this class. We have seen that the induction motor, slip ring induction motor, speed can be controlled by using some inserting some resistance in the series into the rotor circuit, as well as by injecting some voltage into the rotor circuit, or we connecting the two motors, main motor and auxiliary motor. The rotors are coupled and we can change the speed with the 4 methods, variation of the number of poles. Okay. So, these are the speed control of induction motors in the different stator side or rotor side, dear students. These are very small topics and interesting topics. Just you could go through this one. If you are having any doubts, we can see in next class. Thank you for listening my class.